I can't. I have to be good for 5 minutes. So you guys started yesterday, didn't you?
Yep.
A little bit. All right. Your Lewis structure stuff. So when you're drawing the structural formulas of these, just a couple things here. And here's the things I want you to all do. So most of you could draw at least some of them. I'll give you a couple tougher ones today to draw. Figure out the geometry of them. So that would be your shapes, linear, trigonal, plane, trigonal, pyramidal, tetrahedral, all those. You can use your sheet for that. And then be able to figure out the polarity of the molecule. So we've got a few of them up here we'll look at here in a second. Let's look at this thing. Okay. So if I go, this is CH2F2, which looks a little strange there probably. What do you think the central element is in this mess? What do you think, Riley? Carbon. Because it forms the most bonds, right? So what people are forgetting to do is figure out your total valence electrons you can use. So carbon's got 4. You got 2 hydrogens there, and fluorine's got 7 times 2 would be 14, so we've got a total of what, 20? So if we put carbon in the middle and I go a fluorine, a hydrogen, a hydrogen. How many unshared pairs do we need to put around hydrogen? 6?
9.
None. Every one needs 2 electrons, right? And it's got its 2 electrons, so carbons are good, excuse me, hydrogens are good. Fluorines need their 6. Is carbon fine? It's got its 8. So everything's got its 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're good for that. Shape of that is what? What we got for shape? Tetrahedral or trigonal pyramidal? Tetrahedral, because you got the 4 things around there. Remember, you have electrons around the central element. Electrons here, electrons here. They want to be as far away from each other as they can. Why? Why do electrons around the central element want to be as far away from each other as they can? What do 2 negatives do? Natalie?
They push away from each other.
Yes, they repel. So since you have negatives here, negatives here, they want to be as far away as they can. So if you looked at this picture, what would you say the bond angle was from here to here, there to there, there to there, there to there? You would say 90. But 90 is not as far as they can be. Why is that? It looks like 90 is as far as they can be away from each other. Not going to be farther down. 3-dimensionally. So 3-dimensionally would be like this. And look at your angle here. Your angle is bigger than 90 degrees. It's about 190 degrees. So as you're doing these, don't always go by what's on your paper. Make the model, look at it, and figure out why it's the shape it is. Because it doesn't always make it the way it is. People have been making water incorrectly today because of that. Is this molecule polar or nonpolar? Polar or nonpolar molecule? It is polar. I would agree with that. Let's look at that. Okay, so you've got some idea of that. First thing, the bonds. Okay, so the 2 electrons here, 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 and here, they are not shared equally. Who do you think wants electrons more, fluorine or carbon? Who has a stronger pull for electrons or higher electronegativity? Fluorine does. It's got the highest one. So these 2 electrons are being pulled towards fluorine. Bless you. Those towards, I guess we have hydrogen here. So these electrons are being pulled towards fluorine. Carbon, hydrogen, electronegativity, you'd have to look up on the chart. So you said it was a polar molecule. That means you need to have one end that's negative, one end that's positive. Which is which? Where's the negative charge kind of towards? Yeah, but it's a little bit more negative up here. A lot of times they write that as a partial negative like this, and a partial positive down here. So it's got a negative and a positive pole. So when it says polar, it's a dipole. It's got pole here, pole here. I want you to do this for me real quick on paper. With your numerator. I want you to draw this molecule and make it less polar. So there's different degrees of polarity. I want you to draw it so it's a little bit less polar. So to come up with a different way to draw it so it's a little bit less polar. Take a video then for a minute.
No!
I'll go back to for about 5 minutes. So think about how you could draw it where there's not as much charge in one spot.
Hey, no, thank you. So you don't have You suck. I lost one.
Got an idea? What do you got?
Blue sheet that has all of the names of the different shapes.
What?
That's why I was saying.
This, what we're doing now.
I can't do that because carbon down is turning around. So it can't have this.
Hey guys.
All right. What'd you do, Connor?
I doubt it's right.
Good answer.
We just switched the two on the bottom right there.
So like fluorine and hydrogen there?
Yeah.
So you have a fluorine down here, a fluorine up there, hydrogen here, hydrogen here. So now all the negative is not in one spot. It's a little bit more evenly distributed. This might still be a little bit polar. So I've been telling you molecules are either polar or non-polar. There's different degrees of polarity. Remember when I put the iodine in the water and iodine in the alcohol? Remember that? It was all brown when you put it in the alcohol. Remember that at all? Okay. So iodine dissolved in the alcohol. It did not dissolve in the water when we did that. It's probably been a month ago now. But, it slightly dissolves in water. So there's different degrees of polarity as you go through there. Different degrees of them. All right. Here's what you got to do today. You need to, the compounds I gave you yesterday, I need to see the ball and stick models of them. Okay? I need to see the ball and stick models of them. When you are doing those, think about where there are unshared pairs, because you can't see those on here. Like there's unshared pairs around this, it's a plane, and unshared pairs here. So think about where there's unshared pairs, particularly around the central element. Okay? Or when you're figuring out polarity, okay, there's a bunch of electrons up here, this is probably a more negative end, more positive end. So I want you to draw the molecules, make them, at least the last 4 of them that I gave you yesterday. I will come around and ask you questions about the polarity of them. So you'll tell me if it's polar, you'll tell me which side's positive, which side is negative. Alright? You're also going to add in these up here, except for the CH2F2, I just did that once, so don't worry about that one. But you're going to add those in on the back of your paper. So write those down. Right? Give me that.